Okay, you've completed the cylinder functions task. I'm going to work through the remainder of the problems so that you can check your work and see how you did. We first started by writing an equation in function notation, finding the volume of the cylinder given the height of the cylinder. And we did that by taking 9 pi times the height. Using that equation, we found some values for the volume for different values of the height. Now, part C asks us, is this function linear? Explain. Remember that there are 3 tests for a linear function. If a function is linear, then it can be written in slope-intercept form. If a function is linear, then it has a constant rate of change. And if a function is linear, then the graph of the function is a line. If any one of those 3 tests are true, then they are all true. And if any one of those tests is false, they are all false. So is this a linear function? Since we have a table of values, one way to check that is to look at the rate of change. We can see that every time the input increases by 1, the output is increasing by 9 pi. So this has a constant rate of change. The rate of change is 9 pi over 1, which is simply 9 pi. And so we know that this function is linear because it has a constant rate of change. Some of you might have looked at the equation. Notice that this equation is exactly the same as the form y equals m times x. But instead of y, we're using v, and instead of x, we're using h. What's the slope? The slope is 9 pi. And so is this function linear? Yes, because it can be written in slope-intercept form. So I wrote for my answer, yes, the equation is in slope-intercept form and it has a constant rate of change. Remember that as long as one of the 3 tests is true, then all of them are true. So you didn't have to list both reasons, but I did. Now part D says sketch a graph of this function. We know that the graph is going to be linear. So here's my x-axis, or in this case h, and here's my y-axis, or in this case v, and I'm going to scale my x-axis by 1s. And I'm going to scale my y-axis by 9 pi's. This is a special kind of linear relationship that happens to be proportional. It goes through the origin. So I'm just going to scale by 9 pi's. So there's 1 9 pi, 2 9 pi's, 3 9 pi's, 4 9 pi's, 5 9 pi's. So I'm adding 9 pi each time. So when h is 0, v is 0. When h is 1, y is 9 pi. When h is 2, y is 18 pi. All I'm doing is going up 9 pi, right 1. Up 9 pi, right 1. Up 9 pi, right 1. And we can continue this pattern. And there's the graph of this function. So when the radius of a cylinder remains fixed, the resulting equation or relationship between the height and the volume is a linear relationship. Again, when the radius of a function doesn't change, it stays constant, the relationship between the height of a cylinder and its volume is a linear relationship. The volume increases at a constant rate. Okay, let's go to the back side. A cylinder this time has a fixed height of 6 inches. Write an equation of the volume of the cylinder as a function of its radius. Again, use function notation. So this time a fixed height of 6 inches. We know that volume of a cylinder is found using the formula pi r squared times height, but the height isn't going to change. It always is 6. So we have v equals pi r squared times 6. We can simplify that to 6 pi r squared, so it looks nice. And then because it says we want to write this as a function of its radius using function notation, the volume as a function of its radius is 6 pi times its radius squared. R is the input, and V, the volume, is the output. So the volume, dependent on its radius, is equal to 6 pi times its radius squared. Now we're asked to make a table of values for this function. So I'll make a table of values. The input is R, the output is V. And let's pick some values for R. Putting 0 into the function, 6 pi times 0 squared. See, V of 0 equals 6 pi times 0 squared. 0 squared is 0, and 0 times anything will be 0. Which makes sense because if a cylinder has 0 radius, then it also has 0 volume. Putting 1 in for the radius, we have V of 1 is equal to 6 pi times 1 squared. 1 squared is 1, and 1 times 6 pi is still 6 pi. Putting 2 in, we have V of 2 is equal to 6 pi times 2 squared. 2 squared is 4, and 4 times 6 pi's is 24 pi's. Putting 3 in for R, we have V of 3 is equal to 6 pi times 3 squared. 3 squared is 9, and 9 times 6 pi's is 54 pi's. Putting 4 in for the radius, we have V of 4 is equal to 6 pi times 4 squared. 4 squared is 16, and 16 times 6 pi's is 96 pi's. Okay, so now the question says, is the function linear? Again, we'll go through those tests of linearity. If a function is linear, then the equation can be written in slope-intercept form. If a function is linear, then it has a constant rate of change. If a function is linear, then the graph of the function will be a line. If any one of those is true, they are all true. If any one of them is false, they are all false. So if we look at the equation, we can see that there's an r squared. So that right away tells us that it cannot be written in slope-intercept form, because slope-intercept form requires all the exponents to be 1. This has an exponent of 2. So this is not linear because it cannot be written in slope-intercept form. If we try to find a rate of change, we see that the radius is increasing by 1 each time. But here, the volume increases by 6 pi. Then it increases by, increases by 18 pi. Then it increases by 30 pi. Then it increases by 42 pi. And we can see that this does not have a constant rate of change. 6 pi over 1 is not equal to 18 pi over 1. And that's not equal to 30 pi over 1. And so we also know that it is not linear because it does not have a constant rate of change. Is the function linear? Explain. No. The equation cannot be written in slope-intercept form. Neither does it have a constant rate of change. All right, part D. Sketch a graph of the function. So this time the input variable is R and the output value is V. I'm going to just choose to scale by ones again on the x-axis. On the y-axis, however, I might have to I think I'm going to scale by 10 pi's because just to get, when radius is 4, we've got to get clear up to 96 pi's. So scaling by 10 pi's, there's 30 pi's, 40 pi's, 50 pi's, 60 pi's, 70 pi's, 80 pi's, 90 pi's, 100 pi's, 110 pi's. So when r is 0, the volume is 0. When r is 1, v is 6 pi. 6 pi is a little more than halfway between 0 and 10 pi. When r is 2, v is 24 pi. Well, 24 pi is a little bit less than halfway between 20 pi and 30 pi. So a little less than halfway, because halfway would be 25 pi's. When r is 3, we have 54 pi's. 54 pi is almost 55 pi. 55 would be halfway between 50 pi and 60 pi. So 54 pi is just a little bit less than, 55 pi. And then when r is 4, we have 96 pi. 96 pi is a little more than halfway between 90 pi and 100 pi. And so we can see that this is definitely not a linear function. When the height is held constant, the radius and the volume are not in a linear relationship. When the radius is held constant, the height and the volume are in a linear relationship. All right.